Okay, now we're going to do chapter 2, part 2, okay? So we talked about the periodic table. Hope you ran a copy off, or there's a copy in your book, whatever. But it's important to have a periodic table um, available because you need them a lot when you do chemistry. When you're looking at the periodic table, the building blocks elements, the ones that make up pretty much all living things, are carbon, hydrogen, nitrogen, and oxygen. Those are the four main ones, but then phosphorus and sulfur. So those six, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, those are the main things that make up pretty much all living things. Okay? When you're looking at your what they call macronutrients, the ones that you need over 100 milligrams a day, so there's some elements that you need: sodium, potassium, magnesium, calcium, phosphorus, sulfur, and chlorine. Okay, you'll find these in your foods if you eat a balanced diet. If you don't eat a balanced diet, then usually you have to take some sort of multivitamin or something like that to get these nutrients. One that we tend to get too much of is sodium. If you have a problem with your blood pressure and stuff, then they'll try to eliminate some of your sodium in your diet because that does bring your blood pressure up. Okay. We also need micronutrients, small amounts, less than 100 milligrams a day, but we need them for health, for various things. Okay. And those, do I have them on here? Oh, I don't have them on there. Those would be like chromium, zinc. You know, they're listed in your book for all of them. But again, if you eat a balanced diet, you don't have to worry about these. But let's face it, most of us don't eat a balanced diet. So usually if you take like a 1-a-day tablet or some sort of multivitamin, you'll get your macro and micronutrients. Okay. Okay. So we talked about the particles in an atom, and electrons are the ones that are involved in making compounds. Okay. They act as particles and they act as waves. So they're kind of unique in that way. Okay. They have energy. All right. And so what happens with electrons is they like to be in a certain place. It's called their orbital. If you excite them, if you add energy to them, they jump up and they go to a place where they really aren't supposed to be. You know, they move up an energy level. And so when they go back down to the energy level they're supposed to be at, they release that energy and it gives off a certain color. So if you've ever done flame tests, you know what I'm talking about. When you put certain elements in a flame, they give off a certain color. Well, if you really want to know what that element is, because sometimes it's hard to tell if it's dark red or light red, or, you know, there's different colors of red. A machine actually reads the wavelength of the color, and that will tell you exactly what element you have. Okay. The lowest level is the ground level, and that's where electrons need to be. That's where they want to be. That's where they're happiest. But again, if they absorb energy, if you add energy to them, they'll jump up to a higher level, and that's their excited state. Okay, so you can see here, this is level 4. These are the elements in there. When you give them energy, they'll jump up to level 5. But when they go back down, then they have to give off that energy, and that gives that off in a certain color. Okay, so when you're, oops, I'm missing a thing here. Okay, sorry about that. An energy level, which is N, if you're looking at it, would be the rows that they are in the periodic table. Like the first row, which is hydrogen and helium, that's 1. Then you move down to lithium, and lithium across, that's 2, and so far. So N is whatever row they're on. There's 7 of them. But you can figure out how many total electrons they have in the energy level by using N in this formula, 2N squared. So like if you did the first one, which only has 2 elements, hydrogen and helium, put a 1 there. 1 squared is 1 times 2. There's 2 elements. The second has 8 in it. If you think about it, you put a 2 in here. 2 squared is 4 times 2 is 8. So this will tell you how many electrons are in certain energy levels. Okay. Remember that atoms have an equal number of protons and electrons. And electrons fill up their energy levels in order. They have to do the first level before they can fill in the second level. They have to fill in the second level before they can go to the third level. And if you remember from your other biology, there's certain orbitals, there's the s orbitals and the p orbitals and the d orbitals and things like that. Well, they have to go in order, okay? The reason why the noble gases are very, very stable and don't combine with anything is their outer energy level is full. They have 8. 8 is the magic number. It's called an octet. And when you have 8, you don't react anymore. And that's what the noble gases have. The first 20 elements, they fill the energy levels. First they do the 2, and then the 8, and so on. It goes in order. First you fill in the s, and then you fill in the 3p orbitals, which would be 2p, 3p, 4p, so on. So that's where you would get the 8 from. Okay, and then they go in order. But when you get to the D's and the F's, the first D level is actually on the 4th level, but it's 3D. And so they go backwards. And again, if you've had chemistry before, you know what I'm talking about. Okay, so here's the energy levels. The outermost electrons are called valence electrons, and it's what group they're in. So if you're looking at the first column, the alkali metals, they all have 1. If you're looking at the next, the alkali earth metals, they all have 2 because they're in the second column. Remember, we skip over the transition. We go over to like boron, and those guys down have 3, and then 4 and 5. It's the A. You look at the letter A. I don't have one here, so sorry. But again, if you look in your periodic table and the notes I had earlier, you'll see that. Here's showing you the inner electrons. The inner electrons would be the D's, but the S's and the P's, the first 2 columns and the last 6 columns, those are your valence electrons. Those are the ones that are involved in bonding. The ones that go on the inside, those are called the inner core, and they're not involved in bonding. Okay? So the main group elements, again, that would be the first 2 and the last 6. If they have the same amount of valence electrons, then they're in the same family. And that's why they're similar to each other. That's why they react with the same things. Okay? So an ion, now we said atoms are neutral. They have the same number of protons and the same number of neutrons. To form a bond, what happens is atoms sometimes either have to give up electrons or gain electrons. Okay? Because they need 8. 8 is the magic number. So if they lose electrons, let's say they have 1 in their outside, if they lose that 1, then they're stable. Then they lose an electron, they lose a negative charge, they become positive. They're an ion. If they have 7 in their outer energy level and they need to pick up 1, now they've gained an electron, they have a negative 1 charge, now they're a negative ion. Okay? So when you start moving around the electrons, you're making bonds. If they gain electrons, they become negative. If they lose electrons, they become positive. And if they're positively charged ions, are called cations. And I know those of you that had me before heard this before, but the way I remember that cations are positive, if you guys have ever had a cat, you're positive the cat is always in trouble. Because they're always in trouble. That's what they do. That's how cats operate. So that's how I remember it. You don't have to do that, but you know, I'm old. I have to have things to remember things by. I have to have my little tricks. So if it's a negative charged ion, if it's picked up electrons, then it's called an anion. And when you put cations and anions together, you get an ionic bond. You get a new compound. Okay? Metals will lose their electrons and become cations. Nonmetals will gain electrons. That's how they work. So if you put a metal and a nonmetal together, what's going to happen is the metal is going to give its electrons to the nonmetal. Because the metals only have a couple and the nonmetals have a lot. So it's just easier to give them their 1 or 2 than it is for the nonmetal to give up like 6 or 7. They'll always try to do what's easiest to become stable. Okay? The symbol for an ion includes a subscript or a superscript with a charge. It's like like calcium will give up 2 electrons, so it'll become Ca, and then it'll be a +2. And that'll tell you the charge. That'll tell you how many electrons it gives up. Okay? Here's some of the common ions right here. You can see all that first row, they all become +1 because they all have 1 electron to give up. In the second, they have 2 electrons and 2 valence electrons, so they'll give up 2. Here's some of the transition, but a lot of times they have more than 1. These guys over here, you can see some of the negatives. The reasons why the metalloids in here and some of these, they don't form ionic bonds, okay? They form what they call covalent bonds. They share their electrons. And then you can see the noble gases, we don't have anything for those guys because they don't react with anything, okay? If you have, if it could be iron 2 or iron 3, then they use a Roman numeral. So iron Fe with a +3, it would be written iron 3. The Roman numeral is the charge, okay? When we're talking about radiation, okay, radiation, most people are afraid of radiation because they think it's going to give you cancer, and it can. I mean, we have radiation from the sun in the form of heat, but we also have UV particles that could give us skin cancer. But radiation really is high energy electromagnetic radiation, and it comes from electrons, okay? When they move, they can move in 2 different ways, but usually if it's radiation, it's going to move like a wave, and they look at it in terms of how long is the wavelength and how fast is it moving. That's its frequency. Okay, the entire range of the wavelength is known as the electromagnetic spectrum. Okay, it covers not just visible light, the waves we can see, but it covers microwaves and infrared waves and radio waves. So it covers all of them. Actually, the visible spectrum, what we can see, is a really, really small part of it. Okay, visible light, what we can see, is from 400 to 700 nanometers. Okay, that's the length of the wave. They're really tiny. It's not like you can measure them with a ruler. Okay, the shorter the wavelength, the higher the frequency, because they don't have to move as far. Okay, and then they have higher energy. And I think I have a picture here. The longer the wavelength, the lower the frequency, the lower the energy. Okay, so if you want high energy, you want short wavelengths. So you'd want in the 400 range. If you want lower energy, you want in the 700 range. Okay, when we're looking at radioisotopes, we have alpha particles, we have beta particles, and we have X-rays. Okay, certain things can stop. Alpha particles, paper can stop. Okay, when you get to beta particles, you need a little bit heavier duty. And you can see with the X-rays, they go to lead. And if you've ever had an X-ray, you know how the X-ray technician wears those little vests. There's lead in there. Okay, they're protecting themselves so they don't get exposed to a lot of X-rays. Okay, so ionization radiation can dislodge a valence electron. So it will form a cation, but it can damage your ions in your body. Okay, so if you get exposed to these particles, you know, they can cause some problems. If, like in your skin, when we get exposed to UV radiation because we've lost some of our protection, our lead lining, which is the ozone layer. It's not really lead, you guys, but it sounds good. It can damage the DNA on your skin and the cells in your skin, and that's why you get skin cancer. Okay, so the biological effects depends on the penetrating power. Again, these guys have more penetrating power and the energy that they release. Okay, radioisotopes, when they talk about exposure, acute means short term. Okay, if you get a cold, that's an acute disease because, you know, you get it, you're over it, and you're done. A chronic is something that happens all the time. Like if you have asthma, that's chronic. It affects you all the time. So when you get exposure to radiation, if it's a short term, but a lot in a short term, you'll have different effects than if you're exposed to a little bit all the time. Okay, there's radiation sickness, which can result in acute exposure. People that work around a lot of radiation will have like badges that measure it, and they got to be careful about it. And again, your symptoms depends on how much you were exposed to. You can be like, you know, vomiting, or you can maybe just be nauseous, or, you know, things like that. Symptoms generally follow a latent stage, or there really isn't any symptoms. So it just depends on how much exposure. And again, that's acute. That's where you just get exposed and then you're done. It isn't a constant. It's just like a one-time thing. Okay. Benefits of controlled exposure. So like if you're getting cancer treatment, you know, people get exposed to radiation. They're getting exposed to it on purpose to kill the cancer cells. Okay. So the controlled exposure can outweigh the risks. Yeah, you're going to have some issues because of it, but if it destroys the cancer, you know, if you're nauseous, right? And here's some of the things. I'm kind of rushing because I want to get done with this, you guys, before, so we don't have to do another one. But here shows you, when they say LD, that's a lethal dose. Okay, so this tells you the doses. This what's happened. You know, you can see none, temporary decrease in white blood cells, hair loss, fatigue, uncontrolled bleeding. You know, if you get exposed 6 to 10 units, SVs, you can see you can actually die. So you got to be careful with radioisotopes. They actually have a Geiger counter. It clicks. I'm sure you guys have heard them. They'll have a machine that goes da, 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 da. It has audible clicks, and it tells you the frequency, and it'll tell you, you know, how much that radiation is. It warns you that there's radiation. Okay. There's also a radiation badge that those are talking about they wear in their clothes, and it tells them how much they've been exposed to it. So they gotta, you know, can measure it and then decrease if they need to. What a radiation badge has is a special piece of photographic film, and it's exposed to a monitor, and then it, you know, again, it exposes how much radiation they've been exposed to. Oh, good, I got through. Okay, so that's the end of chapter 2. Make sure you do your whatever your assignment is, and then next we'll talk about chapter 3. So we're done for this lecture.